Now suppose this is a metal ion. This is the central metal atom which surrounded by a imaginary symmetrical crystal field. Symmetrical. Now when the ligands came, total number of ligands 6, or maybe coordination number equal to 6. So there are maybe 6 unioned ligands which surrounded the metal as these. 2 axial bonds, this is the axial bond, and 4 equatorial bonds like this. This is the 4 equatorial bonds like this. Now this is the coordination number 6, where there are 6 number of ligands, unit-ended ligand comes like this. Now we already observed that the dx square minus y square and dz square feels much more repulsion than other 3 orbitals like dxy, dyz and dzx. So if these 2 orbital feels much more repulsion, the energy of these 2 particular orbitals gets higher, and the other 3 d orbitals feels much less repulsion, so the energy will be down. So what happens? First we have 5 degenerate orbitals. All the energies of the d orbitals are even same, and first of all the energy of these d orbitals get higher in presence of spherical symmetrical field. Now when the ligands approaches in a particular direction, and the energy of this d orbital in the spherical crystal field, this is known as barycenter. We already have said that the 2 d orbitals, that is dx square and y square, gets some of the higher energy. Suppose, and 3 d orbitals, that is dx square and y square, gets down, and this is known as Eg, and this is known as T2g. Now Eg and T2g, that is dx square minus y square and dz square, and triple degeneracy dxy, dyz, dzx. Okay, this splitting occurs according to the barycenter. Now this total energy difference between 2 different degenerate orbitals is del O, that is O means octahedral crystal field stabilization energy, and from the barycenter, if the distance energy high, this is 3 by 5, that this is 3 by 5 del O, and the energy gap between this is 2 by 5 del O, and total energy difference between T2g and Eg is del O, that is crystal field stabilization energy for octahedral system. Okay.